Okay, so today we're going to look at modeling quadratic relations using graphs. Okay, quadratic relations are used often to model real-life examples, such as projectile motion when a ball is kicked up in the air, or you're throwing a ball in the air, or you're hitting with a baseball bat. Bridges often have a parabolic shape, revenue area. Those are all examples of real-life examples of quadratics. Okay, so for our first example here, we have a table of values that shows the soccer ball's height above the ground over time. Okay, so time is given in seconds and height is given in meters, and it's outlined in here in the table of values. Over time, how high is that soccer ball above the ground? Okay, so the first thing we want to do is we want to graph this information. So when you're going to graph, just remember that time is the x on the x-axis and height is on the y-axis. Okay, so time is on the x-axis and the units for time here is seconds, and I'm getting that information from our table of values. And then height is the y-axis and the units there are meters. Okay, so now we're going to take our values given in our table of values, and we're just going to plot these points on the graph. Okay. Oh, and let's give our graph a title. So the title would be height versus time. All right. So the first point is 0 and 0.1. So again, we're going to do the best we can. If you notice, the scale of the y-axis of height is going up by 1. So we don't have the little tick marks to find exactly the 0.1. But 0.1 is between 0 and 1, but it's closer to 0. So we'll put the dot right there. Okay, so I just graphed that dot. The next dot is 0.5 and 7.8. So again, the point's going to be between 7 and 8, but closer to 8. The next point is 112. That point is actually really nice to graph because we can graph that exactly. We're confident that that's exactly where that point is. The next point is 1.5 and 13.8. So 1.5, 13.8, again, it's between 13 and 14, but closer to 14. The next dot is 12 and 13. That one make 12 and 13. So right there. Then we have 2.5 and 9.75. Again, 9.75 is between 9 and 10, but closer to 10. And that was for the 2.5. So between 9 and 10, just closer to 10. The next dot that we have there is 3 and 4. So 3 and 4. Okay. So we're going to connect our dots there the best we can. I'm going to just reattempt connecting my dots there. As you know, I'm left-handed, so oh goodness, I tilt my paper all kinds of ways. Okay. All right, so there's my dots connected. And now we're going to go ahead and answer these questions. Okay, so what is the maximum height of the ball reached by the ball? So we're talking about maximum height here. So max, that's the key word, max. Remember, parabola is opening down. There's a max. Okay, so that there is the optimal value. And we find the optimal value from finding the vertex of the parabola, and it's the y value of the vertex. So here, that point there would be the max, right? That's the maximum the ball reaches, and then it comes back down. Okay, if you go ahead and look at your table values, that point is this one right here. Okay, so that's the vertex, right? But because that's the vertex right there. But because we're interested in just the max height, they don't care what time it happened at. They just want to know what's the maximum height that the parabola reached. Then we're just interested in the y value of the vertex, which is the optimal value. So the max height there would be 13.8. So therefore, max height of the ball is 13.8 meters. Okay, it's the optimal value. That's the key word there, max. Whenever you say max or min, we're talking about the optimal value, which is the y value of the vertex. Okay, I might write the vertex here, 1.5, 13.8. Okay, now the next question is, how long was the ball in the air? Well, our graph kind of falls a little short, so we're just going to have to kind of extend it. Extend it there. And again, you know, it's not perfect because we don't have, like, we're just going to kind of guess when the ball hits the ground, because our tick marks or our scale doesn't allow us to say it perfectly. Okay, so there we just guess the ball. Oh, and here they want, sorry, so the ball hits the ground there, and what they're interested is in how long, right? That's the key word in this question, how long. So how long, they're looking for time. Okay, so this is what they're actually interested in here, is how long was it in the air? When did it hit the ground? Okay, so if we're going to just estimate that, we can say it's like 3.2 seconds. Okay, so therefore, ball was in the air for 3.2 seconds.